Hello guys, welcome back to my channel. Today we are gonna solve LeetCode problem number 206, reverse linked list. This is an easy problem. Let's just quickly go through the description once. Given the head of a singly linked list, reverse the list and return the reverse list. Okay, so we have a linked list over here, 1 2 3 4 5, and we have to reverse it. So like in the initial condition, 1 is pointing to 2, 2 is pointing to 3, 3 to 4, 4 to 5. So basically this arrows, this pointers we have to reverse. uh, if we reverse this pointers, then we'll get the expected output, right? Let's just go through one of the example. Here 1 is pointing to 2. We have, if we reverse this arrow, then like 2 will be pointing to 1. And if in case of an empty linked list, we can give a output as empty linked list. Fine. So here we have a to find, we can find the time complexity using constraint. So the range is 0 to 5000. That means the time complexity should be log of n, like O of n, or n log n. This 2 can be the time complexity. Fine. What we can do in here is, here in the first step, we know what is the next pointer, but if you move to the second step, right, um, this will not know what was previous to this. Like 2 will not know what is previous to this. This is the way like pointer works. The node has information on of only the next element. So like it only has one pointers. So basically if you introduce two pointers, so in that way node will have the knowledge of previous node as well, and then we can assign that previous node as a next node to this particular node, right? So basically, like 1 is pointing to 2 and 2 is pointing to 3. If 2 has knowledge of 1 and 3, so basically what 2 is going to do is we can store this 2 is pointing to 2 in a variable, that in that way we will know the address of 3. But this 2 dot next, like the next pointer, we can shift this to 1. You got it? So right now the next is 2 to 3. We can store this next 2 to 3 in a temporary variable, and then we can move this 2 to 3 to 2 to 1. So like for 2 the next will be 1. Same if we do with this, uh, if we go in here, we have address of 3 now, right, in our temporary variable. So if we do the same, then 3 will point to 2. So eventually we will get the uh, below output. So let's start coding this. Firstly we'll create a pointer that's none, right? So in the current condition, what it is pointing to, it's pointing nothing. Previous pointer for this is none. Then we'll create a current pointer, that's basically head. So basically start with current at the head of the list. So initially we know head is a head is a address to the first element. Yeah. So current is head as of. Then what we can do, we can create a while loop for doing the iteration. So if current is none, so in C we have a concept of null, but here phi is not pointing to null. We in C, in Python we say it none. So if right now phi is pointing to none in here, um, so we can create a while loop, and if if in case current is nothing, then like it will break the loop. So we'll create a temporary variable. Temporary variable will hold the next like next pointer. So 2 is pointing to 3. We are gonna store this particular thing in temporary variable. Then what we can do is we can do the classic swipe sort method. So earlier in sorting, like in sorting, you might have done the swipe method. So same we can do in here. So current next is previous. So what we have done, we have stored this 2 to 3 in temporary and current next. So this particular arrow we have shifted to 1. Now it's pointing to 1, and in case of 1 it's pointing to none or null, right? And previous equals to current, and current e- equal to temp. So basically this step we are storing the node. Here we are reversing the pointer. Now we are moving the previous node forward, and in the last line we are moving current forward. Got it? Yeah. So in the end, what this gonna return? Return Brave. Brave is the new head of the linked list, as we can see. So it will return previous. Let's just quickly try run this and let's see what we get. So this is passing the test case. Let's try it for the hidden test case scenario as well. We'll submit this and let's see if it passes all the hidden test cases or not. Oh, so it's passing all the test cases, and we are getting like it's beating 100% of the submissions. So like this is one of the best solution. I like I also didn't expect it will cross 100%, to be honest. Because this is a simple method. I thought everyone would have done this. So but weird, but yeah, great. Obviously, our like memory uh, complexity is not that great, but it's fine. We only focuses on runtime complexity. That's it for today, guys. Thank you for watching my video. Let's see. Let's meet tomorrow. Thanks.